Welcome back after technical difficulties. Part 2 of my barrel video being turned into a clock, which is actually where the geometry is going to come in. So this part of the video is going to be about some geometry, specifically circles. So here is the top of that barrel. Earlier today, my son and I cut this off. Now, in order to cut this off, a couple things first I want you to see is that there's a groove cut all the way around, and in barrel lingo, that's called the croze, C-R-O-Z-E. So those of you that play Scrabble, you got a good word with Z, C-R-O-Z, it's called the croze. So that's called the croze, and these boards fit into that groove. So there's it's kind of like a tongue and groove technology going on there. And why is that? Well, because when this wood swells, when there's liquid inside, then it'll seal completely and it won't leak. So you'll notice that this top is not one board. I don't know if you can see it on camera, but there's a seam here, there's a seam here, there's another seam here, another here. So these are all random width boards going across. And this is fairly flat. So this is going to make a nice clock. So you'll notice that one of the things that my son and I had to do is we had to put a screw in through the metal hoop into every stave. So if we look at the back side, now you can readily see how many boards. So it's 1, 2, 3, 4, 5, 6, 7. There's 9 boards make up the top of this barrel. You can see the groove here. You can see my pencil going down into there. Notice how some of these, the unions between the staves are opening up on the inside. Notice they're not cut at a 90-degree angle. If they were cut at 90, it wouldn't make a circle. So these had to be cut at this angle in order, so there's some geometry there. Now, what's that angle, you ask? Well, that angle depends on how many of those unions we have all the way around. Okay, so some simple division there. What number are we going to use? 360 degrees. Okay, so, and you can see the charring that took place inside this barrel. Now, this barrel was probably in use for several decades. I know it's been sitting in my friend's barn for about 20 years, so it's very, very dry, as you can see by how open the unions are, the joints are. But even though this was used for decades before it sat idle in my friend's barn, now it's going to be repurposed. Some people use the word repurpose. Some people use the word upcycle. Those are very popular words right now. Now it's going to be a clock. And this top here, and as you can see, these boards are 1 inch thick. So these are pretty thick boards. This probably weighs 10 or 12 pounds. So, but this is going to hang on somebody's wall and be a clock. And what will happen here, the biggest thing, the reason why I was thinking about this project for geometry class, and I'm uploading it to all of my classes because I think that my other classes would be interested in watching this, because it's just a chill out video. There's no assignment going with it. So the problem that we face is if I'm going to put a clock mechanism on here, well, what's really important about that clock? That I have the exact center of this circle. The exact center. The exact. If you're looking at this clock from across the room and that center is off, I would say probably even by a 1/4 of an inch would be a lot. If that's off and you look at it from across the room, it's going to look terrible. And if you're OCD, like many people are, you're going to look at it and be like, something's wrong there. Something's wrong. Something is wrong. So I have to find the exact center of this circle. So the one thing that we don't want to do, if you ask the average person, let's find the exact center. Well, how do you find the center? Well, the center is halfway across the diameter. So now if I get out a tape measure and I start measuring, and I look and I say, well, yeah, that's about the biggest spot right there. I'll draw a line, and then I'll come over here and I'll swing it, and that's pretty close. You're going to get close, but you're not going to be spot on. Why are you not going to be spot on? Well, it's simple, because if you look at this, there's a gap now between the hoop and the wood. And it's not perfect all the way around. So we can come up with a better method. I don't want to be close. Okay? My name is going to be attached to this. So now we're drawing in some pride. Now we're drawing in some craftsmanship and some work ethic. If my name is attached to this, I don't want close. I want it perfect. And since I'm also a mathematician, I can make that center exactly perfect. So if we were still in school, it's the month of May, we would probably be into chapter 11. Chapter 11 is really cool stuff about circles. Unfortunately, we're probably not going to, we might do a little bit of chapter 11 between now and the end of the year. But we have to take care of the trig and the SOHCAHTOA stuff first, which is coming. Those videos are coming. But if we were in school, we'd be in chapter 11, and we would be learning some of this stuff. So the first thing we need to learn is the word tangent. Tangent is a line that just barely touches. So if I take this ruler and I just barely touch the outside of that circle, okay, here's a circle. Okay, I got driver bits in here. That's a circle. If a line just barely touches the outside of that circle, it touches one time. That's called a tangent line. We just abbreviate, call it tan line. You know, like in the summer when you catch a tan. It's a tan line. Okay? So, one thing we could do, there's a theorem that says, well, if you have two tangent lines and they intersect, and I cut that angle in half, the center will be on there somewhere. So, oops, I gotta get a fresh pencil. So, we have this little tool in my shop, which I use this a lot in my wood turning when I want to find the center of a round object. So basically what this is a V notch. And there's two different sizes, and you'll see there's a straight edge in there. So if I put this round object in there, basically what's happening is these little things, these little plastic ridges, are acting as two tangent lines. And then I can draw on there a line, and that line, because that's bisecting that angle, that's a diameter. Well, now I have a diameter, I still don't know the center. What could I do? Well, I could measure it, but what if it's 3 and 11/16? Quick. What's half of 3 and 11/16? Yeah. I don't want to do that. What if I just rotate it and do the same thing again? If I do the same thing again and draw that line, now where they intersect is the exact center. Okay? I could do that here. The problem is I don't have a ruler long enough. I'd have to put boards together. That just seems cumbersome. Doesn't seem very slick to me. This tool gave me an idea, but I don't think I want to do that idea. So there's two ways of finding the center of the circle that I'm just shooting down. If it's small, this little gadget could work. I really don't want to cut two boards and join them and then I have to find the center of that angle. That's bisecting that. I don't like it. There's a third way I could do it. I could take boards and square this off so that I have, like, I could put a tangent line here, I can put one here, and I can box it in. I don't have enough things here. I can put a rectangle or a square around this with boards. And then once I have, like, say it'll be a square. Once I have a square, I can connect corner to corner, and that'll give me the middle. But again, that requires boards and kind of drilling holes and screwing things together, I don't like it. There's a slicker way. There's a much better way. And it uses something that we just learned about that was on your quiz. And it uses chords. So do you remember what a chord was? A chord is, cameraman, is this fully visible on the screen? Okay, so I'm going to put this down here and I'm going to draw, that's going to be a chord, okay? Now, that's a chord. Right there is the halfway point. So there's a theorem in chapter 11, which we didn't get to yet, that says if you draw a chord, any chord, on a circle, and you put the perpendicular bisector through the chord, the center is somewhere on that line. And if you think about that, you think about what a chord is. What's a chord do? Edge to edge, but not necessarily through the center. And then if I make a right angle to it, at the middle, perpendicular bisector. We haven't talked about that word in probably since October. What's a perpendicular bisector? Well, perpendicular means right angle. Bisect means smack dab in the middle at the midpoint. So here I have, boom. This ruler is 12 inches. This is a 1 foot ruler. The 6-inch mark is what I'm interested in. So all I have to do is I take my square, put this square on here, line that up, and I got a line. You probably won't be able to see that line on there, but there's that line. That's a perpendicular bisector to the chord. I'm going to extend that line. I doubt you'll be able to see all this because it's pencil. I'm not drawing. I was going to use a marker, but since this is going to be the clock face, I didn't really want to put marker on there or chalk or anything because I have to clean this up. So there's a line. Now I'm going to do that again. Somewhere, the theorem, the geometry says somewhere on that line is the center, but I still don't know exactly where it is. But Mr. Liscanen, you could take that diameter. If the center's on there, you could draw it all the way to the end, and then you have a diameter, and then you just cut it in half. I could do that. But again, I run into the same problem before. Why do I want to do math when I can do geometry? Because I know that this is roughly 21.5 inches across, but it doesn't mean that it's going to be a perfect 21.5. So, you know, if it's like 21 3/8, now I have to 21 3/8 divided by 2. You know what? I don't want to do that problem if I don't have to. I have a better way, and I know that none of you would want to cut that number in half because when we measure with tape measures and rulers, we get weird numbers. And we don't like cutting those numbers in half because they're fractions. So here's what I'm going to do. If somewhere on there is the center, I'm going to do that process again. I'm just going to come over here. I can make any chord I want. I'll just go right here. Boom, there's a chord. There's the 6-inch mark. I go 90 degrees from it. Draw my perpendicular bisector line. There it is. Take my ruler. I'm going to extend it. I'm going to put it right on that line, and I'm going to extend it. Right here. That point is the exact center of that circle. Now, just to be sure, if I make a third chord and a third perpendicular bisector, it should go right through there, shouldn't it? It should. If it doesn't, something's off a little bit. Put a chord over here. 6-inch mark, bisector, boom. Okay, let's go maybe like this. We'll go about like that. We've got, boom. If I extend that, boom, right through there. I just check my work by doing it a third time. That is the center of that circle. And this is a common problem. Now, if we go back, let me get my tape measure. If I measure across and I make sure that goes right through there, boom, 21, it's roughly 21 and a half. What's half of 21 and a half? 10 and, you know, it's almost 11, right? I'm almost at 11, about 10 3/4. That's where it's telling me. If I measure this way, pretty close, all the way around. It should be pretty close. Okay, so, you know, this hoop isn't perfect, but we're finding the center of this interior circle. Finding the center of a circle, there's lots of ways to do it. Some ways are better than others. Using geometry, you know, in the construction trades, there's this old saying: work smarter, not harder. And that's exactly what this is. This is working smart, a little bit of knowledge. Now, unfortunately, we didn't get to chapter 11 because of the school closure. So we never really got to this theorem. But here it is. You're just doing a chord and a perpendicular bisector to it. Again, could have used the tangent line method. Okay. There's a tangent line. I drew this tangent line. I don't know if you can see it on there. It's a circle with just a line cutting it. By the way, if you draw a line like this, does this show up on camera? Is that showing up on camera?
Yeah.
Okay. So this line over here, this is called a tangent line. There is a relationship between that line and the tangent that we'll do in trig coming up real soon, but we don't need to know what that relationship is. This, you might notice from edge to edge, that's a chord, but if it goes all the way through the circle, it's called a secant line. And again, there's some theorems that go with secant lines, secant, S-E-C-A-N-T. So a secant line is basically, when I do this, from here to here, that's a chord, but if the line gets extended, it's called a secant line. And so a diameter, every diameter is a chord, but not every chord is a diameter. And the same thing, every diameter is part of a secant line, but not every secant line has a diameter. And why? Because you're not going through the center. So, look at that. We talked about a lot of different things with a barrel, and you probably have seen these barrels around, and there's so much stuff going on here, and I just thought it was kind of cool to share some of this stuff. And really it was this geometry problem at the end, and I kind of talked about some of the other things. So the focus was, how do we find the center, which we did. I hope that looks like the center. I don't know if you can see right there is the center. So that looks like the center. I promise when I get this clock finished, I will post a picture on Google Classroom so you can see what the clock looks like, because I should have it done within about a week or so. The hard part's over. Pretty much I just got to drill a hole, and then I'll just paint this metal. We don't want that rusty metal and those silver screws, so all that will get painted black. The inside in here, what I'll do is I'll sand this real light just to remove some of the dirt and remove my pencil marks. I'll sand that, and we'll probably just, I won't even stain it or anything. I'll probably just seal it up, because see this nice gray weathered edge of these staves? That's called patina, and that's very rustic looking. So I'll probably just sand this just lightly, just to take off some of this dirt and some of my, of course, my pencil marks, and I'll probably let it natural, but I will seal it. I'll probably seal it with some clear shellac, and I'll definitely, the back, all this charred stuff is going to flake, so I'll spray that with shellac. I'll probably wire brush that to release the flakiness, and then I'll spray it with several coats of shellac outside. Hopefully we have a nicer day than today when it's snowing, and then I'll all get sealed, because back here somewhere I got to put a really stout method of hanging this on the wall. So, although we could probably just use the lip up here. So, one last thing. If that's the center, I'm going to put that mechanism through here. My hands will go around. I got to put numbers in. The numbers are going to be corks because that's going to look cool. It goes with the theme. Okay, so quick question. One more geometry question before we wrap things up. How far apart are those numbers going to go? And how do I figure that out? Well, hopefully you're thinking about it. How many degrees are in a circle? 360. How many numbers are? 12, right? So each number is how many degrees apart? 360 divided by 12. I'll give you a second to figure that out. Figured it out yet? 30 degrees, right? So what I would probably do is I would probably lay one of my bigger rulers across here, make a diameter 12, 6, lay my square, get 90, 9, 3, and then in between there, boom, from the 9 go 30 for the 10, go 30, and then go 30 in between. Okay, so that's actually an easy process because I don't even have to make any marks on here. I can just set up my squares and my lines and whatnot. So that's the last phase of it. But I do promise I will show you a picture of what this looks like. I hope that you just enjoyed this video. There's a lot of cool stuff going on in this project. I had to research barrel making to figure out what was going on. I didn't want to just cut it because if I just cut it without the screws, it would have all fell apart. Then I wouldn't have had anything. I wanted to keep the hoop. I wanted to keep that metal because that metal is going to make it look cool. It doesn't look cool now. It's all rusty and there's marks on it from being rolled around on the ground or whatever. But when it's painted black, I'll paint that black. So yeah, this barrel is out of commission from holding liquid forever. It'll never hold liquid again. But it's gonna be in commission telling time for I don't know how long, decades to come. So I hope you enjoyed this video. I hope you enjoyed the process. And there's a lot of cool stuff happening in my workshop. I thought this was a very unique project and it brought in some geometry, and it just so happened that we were talking about circles. So until next time, I want you to take care and hey, get outside and do stuff. Hey, clean your room too. You probably need to clean your room, I'll bet. Get up early and clean your room. Anyway, we'll see you later. Hey, by the way, I hope you like my hat. I like it. Catch you later. See ya.